Okay, so this is going to be part 2 of 7-1, and we're looking at some word problems and solving systems of equations here. So the situation that we have is a chemist working on a flu vaccine needs to mix 10% of sodium iodine solution with a 60% sodium iodine solution to obtain 50 milliliters of a 30% sodium iodine solution. How many milliliters of the 10% and 60% sodium iodine solutions should be mixed? So let's go ahead and make a chart here to organize some of our information. We have different percents of solutions, so solution percent. We have a 10%, a 60%, and we want a 30%. Okay. Now, we also want to talk about the number of milliliters of each of those solutions that we need. And we want to convert those percents into decimals. So decimal percent sodium iodine. Okay. So let's see, 10% would be 0.1, 0.6, and 0.3. And then how much, like the total amount of each type, the amount of sodium iodine that we actually have. So the percentage times the actual amount of milliliters. Now, we're trying to find out how much of the 10 and how much of the 60. So we don't know how much of each of those we actually need, but we do know that we want 50 milliliters of the 30%. Okay, we want 50 milliliters. So, however many milliliters of the 10% times 10% would give us how much sodium iodine we actually have from that, how much sodium iodine we have from the 60, and then same thing, 50 times 0.3 is 15. So we can write some equations here. We know that x plus y is going to equal 50. However much of this plus however much of this needs to equal 50. And we know that however much of this plus however much of this is going to equal 15. So what we can do now is multiply this bottom equation by -10. That'll move all of our decimal places over for us and allow us to solve for our variables. So we have x plus y equals 50, and we have -x minus 6y equals -150. And x's cancel. We have -5y is equal to -100. So y equals 20. So what that means is we have 20 milliliters of the 60% solution. And if we had a total of 50, that would give us 30 milliliters of the 10% solution. So we always want to answer the question in terms of what they're looking for, not in terms of x and y. Nowhere in the question did they give us x and y. We invented x and y. So we always want to make sure that we're answering it in terms of what the question is actually asking us for. So I'm going to go ahead and move the page up here to our next example. Now it says, when a small plane flies with the wind, it can travel 450 miles in 3 hours. When the same plane flies in the opposite direction, it takes 5 hours to go the same distance. Find the average velocity of the plane in still air and the average velocity of the wind. Now, these problems are called DIRT problems, D equals RT. Distance is equal to rate times time, okay? So that's what we're going to be using here. We have a small plane, and I'm not an artist, so this is my picture of a plane. And we're going with the wind, and it takes us 3 hours to go 450 miles. Now going in the opposite direction against the wind, it took us 5 hours. So we can use this information here to draw a table and to figure out, what it's asking for. Now, it's asking for the average velocity of the plane, so that's what our variables are going to be. X is going to be the average velocity of the plane in still air, meaning no wind, and then it's also asking for the average velocity of the wind. So we can use those to make a table. So this is the trip with the wind and the trip against the wind. Okay, and velocity or a rate, and our time, and those two multiplied are going to give us our distance. Okay, so we're looking for the velocity of the trip with the wind. So that would be the velocity of the plane plus the velocity of the wind. Now, if that's what it is going with the wind, going against the wind is going to be the velocity of the plane minus the wind. And we know that the plane has to be faster than the wind. So if we're going to do that, then if we have the speed of the plane here, we know the wind has to be slower than that so that we're not being slowed down or going in reverse because of the wind. Now, going with the wind, it took us 3 hours. Going against the wind, it took us 5 hours. And so we can multiply those, 3 times x plus y. And we know the distance. They told us it was 450 miles. And then we can do the same thing here. 5 times x minus y equals 450 as well. And now we have two equations that we can solve. I'm starting to run out of room here, so I'm going to move it over here. And we have 3x plus 3y equals 450. 5x minus 5y equals 450. I can divide this equation by 3 and divide this one by 5, and I'll have x plus y equals 150. X minus y equals 90. Y's can cancel. X is equal to 120. And we know that x plus y equals 150, so y has to equal 30. And what that actually means in terms of this question is the average velocity of the plane in still air is 120 miles per hour. Squeeze that in there. And then the average velocity of the wind is 30 miles per hour. And that's our answer. And that is the end of 7-1.